How were planets formed in the early universe? The James Webb Telescope answered this question. Space scientists once believed that planets were very difficult to form in the early universe, and later the conditions around the stars became more favorable for the process of planetary formation, but 20 years ago photographs from the Hubble Telescope doubted this. So far, space studies have shown that the formation of planets in the beginning of the universe was not as easy as it happens later. Scientists had received many signs of this, but 20 years ago, the Hubble telescope saw something else contrary to this assumption, which made scientists look somewhat confused. Now recently, by studying the images of NASA's James Webb Space Telescope, scientists have been able to confirm that Hubble's suspicion was right and the thinking of scientists so far was wrong. 20 years ago, images from the Hubble telescope indicated that planets could form and survive in the harsh environments of early cosmic stars, and in 2003 Hubble discovered a large planet orbiting an old star as old as the universe itself, a discovery that confused scientists because scientists believed that heavy elements and metals are very few in old stars. These elements are very important for the formation of the planet. So far, theories show that planets cannot form in such a situation because the disk gas and dust around such stars would disappear quickly. To solve the mystery, scientists used NASA's James Webb Space Telescope to study the star cluster NGC 346 inside the Small Magellanic Cloud, near the Milky Way galaxy. This galaxy lacks heavy elements, and because of this it is an ideal place to describe the conditions of the early universe. When James Webb studied it, it was found that the disks of this group of stars still have planet-forming disks, and they are also much longer than expected. This discovery is a great discovery for planetary formation science. This means that the disk of stars with harsh atmospheres can last for hundreds of millions of years. At least it's a lot longer than it seemed. In such a situation, the planets would have had a lot of time to form and flourish here, and even huge planets like Jupiter can flourish here. Scientists now know that planets will begin to form when the universe is young, and that there are two possible reasons why the disk persists for so long. The first is that in areas where there were fewer heavy metals, due to low or slow radiation, the stars would have taken more time to remove or blow away gas and dust from there. Another reason for this could be that stars in these environments have started forming large disks, which may have lengthened their lifespan before they expired. The discovery challenges the notion that planets were less formed in the early universe. But now it seems that even in the early universe, more planets were formed. This study has been published in the Astrophysical Journal. It is worth mentioning that the confusion created by Hubble saw in his photographs was named the impossible planet problem. Hubble's observations were correct, but they were not enough to draw confirmed conclusions, which are now claimed to have been solved by observations from James Webb Space. The process of forming planets in the early universe was complex and time-consuming. To understand this, we have to understand the formation of the universe, the formation of stars, and the formation of planets. The process of formation of planets is associated with the early age of the universe. To understand this more deeply, we will look at some more important aspects associated with this process. This process took place mainly in the following steps: the Big Bang and the making of primary content. The universe originated from the Big Bang about 13.8 billion years ago. The early universe consisted mainly of hydrogen, helium, and small amounts of lithium. These gases dissipated in the form of large clouds. Condensation of gas and dust clouds. Gaseous clouds of hydrogen and helium, called nebulae, began to shrink due to gravity. When these clouds became denser, the temperature and pressure at their center began to rise, causing stars to form. Collapse and rotation of nebula. When giant gaseous and dust clouds, nebulae, begin to shrink due to gravity, their rotational speed accelerates. This is the same principle seen in an ice skater accelerating when he brings his hands in. This rotational motion gives the protoplanetary disk a flattened shape. The density of the disk is higher the closer to the star and less at the edges. Formation of wires. In the center of these dense clouds of gas and dust began the process of nuclear fusion, which formed stars. During the formation of the star, a disk of dust and gas, called a protoplanetary disk, revolving around it remained. Development of protoplanetary disk. This protoplanetary disk revolving around stars provides the primary material for planet formation. In this, small particles start sticking to each other due to the effect of gravity and static electricity. Formation of planetary seeds, planetesimals. Small particles of dust and gas present in the disk combine to form large pieces, planetesimals. These fragments can grow to a diameter of a few kilometers. Formation of planetary protoplanets and collisions of planetesimals. Small rocky bodies begin to form after the gas and dust particles join together. These objects change into larger-sized bodies under the influence of gravity. Many protoplanets collide with each other during early planetary formation, and this collision enlarges the size of the planets. The planetesimals continue to collide and condense with each other, forming larger bodies. These are called protoplanets. They tend to pull more material to themselves due to gravity. Finality of planets and temperature gradient. The type of planets, rocky or gaseous, is determined by how far they form from the star. Gas accretion. Giant planets of gases, such as Jupiter and Saturn, pull gases such as hydrogen and helium due to their large gravitational force. This process is the main reason for the formation of gas giants. This shape of the outer planets helps them to remain stable for a long time. Near the star, due to high temperatures, only heavy elements such as metals and silicates remain solid. This is the reason why rocky planets like Earth, Mars, Mercury, and Venus were formed. Far from the star, in cold regions, gases like water, ammonia, and methane can freeze as ice. These gas and ice are helpful in the formation of outer planets, e.g. Jupiter, Saturn. Stationary planets are formed after the process of collision between protoplanets and the accumulation of material. Their nature depends on how far they are located from the star. Large planets of gas, such as Jupiter and Saturn, these formed mainly in the outer region, where there were cooler temperatures and greater amounts of gas. Rocky planets, such as Earth and Mars, these formed close to the star, where there was solid material such as metals and silicates. Maturation of planets. Even after the formation of planets, their surface and interior continued to evolve. Falling meteors, volcanic activity, and the formation of the atmosphere caused the planets to reach their current positions. Formation of moons and rings. The material surrounding the planets also turns into tiny bodies, which form the moons. The rings of Saturn and the moons of other gaseous planets formed in a similar way. Sometimes debris from collisions is also helpful in forming the moon. Example, Earth's moon is believed to have formed from a giant collision. Atmosphere formation. Some of those planets gained atmospheres after they became planets. Rocky planetary atmosphere, formed by volcanic activities and gases ejection. Gaseous planetary atmosphere, formed by pulling huge amounts of gas. Orbital stabilization. The orbits of the planets in early times were not stable. The gravitational influence between the planets and the fragments they formed played an important role in stabilizing the orbits. Large planets such as Jupiter and Saturn played a role in pushing out smaller planets, forming structures such as the Kuiper belt and the Oort cloud. Habitable planets. The surface of the planets and their orbits decide the prospects for life. Earth, due to its distance, temperature, and availability of water, it became suitable for life. Similar signs of life are being discovered on other planets, most notably Mars and the moons of Jupiter such as Europa. Planet formation continues to this day. New stars and planets are still forming in our universe. Protoplanetary disks have been observed in distant nebulae, showing that the process of planet formation is still active. Astronomers have discovered hundreds of such exoplanets, planets outside our solar system. In this way, planets were formed by a combination of cosmic dust and gas condensation, gravity, and many complex processes. This process was completed over millions of years and continues in parts even today. The formation of planets is an amazing process of the universe, occurring through the complex interactions of gas, dust, and gravity. This process not only helps us understand the origin of our solar system, but also helps us know the possibilities of life in other galaxies.